What makes us human? In an effort to understand what makes us human, neuroscientists set out to create a complete map of the human brain. This is to chart where every neuron connects to every other neuron. The problem is, the brain has more connections than the Milky Way has stars. Just 1/1,000,000th of the organ contains more information than all the written works in the Library of Congress. A map of the brain would represent the single largest dataset ever collected about anything in the history of the world. Making such a map seems like a task that could consume not just one lifetime, but dozens. Yet in just 3 years, it might just be possible. A supercomputer, called Aurora 21, will run 1 quintillion operations in parallel, putting it on par with the processing power of the human brain. The computer will occupy around a quarter acre, have thousands of miles of wiring, and consume electricity for a medium-sized city, expected to cost hundreds of millions of dollars. This one holds particular promise for neuroscience in providing the capacity to simulate the brain. The supercomputer could illuminate the largely mysterious processes that underpin human learning, behavior, and even psychiatric disorders. Castari, a neuroscientist at Argonne National Laboratory, is one of many scientists whose research will use this new supercomputer, which is scheduled to be deployed by 2021. Mishla Torfer, professor of high-performance computing at the University of Tennessee, Knoxville, says, "The metric of success is what kind of science you enable, and we need this kind of idiot-savant brain to understand the real brain." Castari was struck by the fact that a fruit fly hatches from its egg fully competent, already knowing how to fly, while a human baby is born so utterly helpless that it will die of starvation without someone to feed it. This helplessness and the years we spend developing into functional adults, had to be key to what makes us human. We are born with a blank slate of some 100 billion neurons that get arranged and rearranged over time to create the hardware we run on. But no one really understands how, exactly, that hardware is wired. So it's at the level of these neurons that Castari has set out to explore the brain. With the help of Aurora 21, he will be able to piece together millions of two-dimensional images, reconstructing the brain in 3 dimensions, essentially creating a map, known as a connectome. In many ways, it's like a city map. That map of the streets in the city is going to tell you something about what that dynamic city is like which parts sustain the most traffic and which parts are directly connected to others. The most interesting findings will come from how does the connectome vary between 2 adults with different skills. Between an adult and a baby? Is there only one plan for a brain that can problem solve? Or is there more than one way? The structure of the brain is just a starting point. Castari hopes to combine a structural map with collaborators' maps of the brain's electrical activity, or traffic, to see how the two together influence a person's learning and behavior. Susie Huang, a radiologist at Massachusetts General Hospital and researcher with the Human Connectome Project, says that many disorders, such as autism and schizophrenia, are likely rooted in anomalies in the structure of neurons. MRI and other current brain imaging methods are too coarse and can't easily suss out such anomalies. They can't tie together cause and effect. If successful, the technology could make waves in the medical field. A fine-grained map of the brain could change that, and help doctors diagnose psychiatric disorders or possibly even predict them. Aurora 21 will be the beginning of more collaborative and ambitious neuroscience. The holy grail of neuroscience was to break the neural code, that is, to read the activity of every neuron in the brain and map that activity to a behavior. It was a goal separate from Castari's connectome but similar in scope. The supercomputers like Aurora 21 swing open the door to possibilities that don't exist in real life, the ability to test medicine, infrastructure, even weaponry free of the cost, safety, and ethical concerns that constrain real-life experiments. Predicting the weather to assessing the safety of our aging bridges and fighting common diseases like Alzheimer's. Thanks.